Thank you very much for your presence in this talk and on this conference. I am happy to meet again this group of old friends. And in this occasion, I will share this presentation, this talk, with a Mexican friend of the Instituto of Philosophical Studies in Mexico City. We will divide the talk into parts. I will start and Gustavo will end about it. Well, I will start quickly. So this is about the ethics of the future of chemistry. In a few years ago, the Royal Society of Chemistry produced a booklet about the future of the chemical science. Just to remember, the Royal Society of Chemistry is the first society of chemistry in the world, and they were celebrating the 155th anniversary. And the idea is to think about the future. And based on these discussions, a lot of discussion around 2 years, they developed for 4 surprising but plausible scenarios, which they use to inform the planning of the future of chemistry. The 4 scenarios were: the number 1, chemistry saves the world. And the important things here is that the chemical sciences, provide answers to many of the questions of the future, and we are in the future now, and explore what would happen to the chemical science if chemists solve some of the world's great challenges. This is the optimistic scenario. The number 2 is the push button chemistry, and it's about artificial intelligence, for example. And in short, this scenario explores a world where the chemical sciences are automated and decentralized. This is the main point. The third one is a world without chemists. They say today chemistry has broadened its horizons even further and separated entirely into subdisciplines. Without the chemical sciences as a distinct discipline and university subject, the pipeline of future chemistry starts to dry up. And the fourth scenario is the free market chemistry. In this scenario, we explore a future without public funding for the chemical science. So we start to discuss, we want to discuss these 4 scenarios, the ethical behind these 4 scenarios. And we agree with this recent book of Joachim Schumer about the ethics of chemistry. And the idea that this is an academic field that studies the moral values, norms, judgments, and virtues relevant to chemistry with the aim of providing moral guidance from a general ethics perspective. This is the main point. So we will talk about each of the 4 scenarios. The first one, chemistry saves the world. And the idea is, since the 18th century, with the emergence of chemistry as an independent discipline, a teaching discipline, with its own robust scientific practice accompanied by a powerful and flourishing industry, the word responsibility has been incorporated into the vocabulary of chemical practices. This is not a simple idea, because derived from the French Revolution and the Industrial Revolution, the conviction that we must assume without excuse or no possible remedy our own horrors. And Farsad just talked about the war and the concentration camps in a way, as something to be accounted for. it's necessary for us. So with this, the most important general idea is the precautionary principle, and this is the version of the UNESCO a few years ago. And I was just share with you the red lines. When human activities may lead to morally unacceptable harm that is scientifically plausible but uncertain, actions shall be taken to avoid or diminish that harm. Morally unacceptable harm refers to harms to humans or the environment that is threatening to human life or health, or serious and effectively irreversible or inequitable to present or future generations, or imposed without adequate consideration of the human rights or those affected. And this is the main idea behind responsibility. So the precautionary principle is necessary because for this reason, the need to mediate between the opinions of technical experts and the people affected is becoming clear. This is essential to specify, at least within the chemical communities, the procedures for deliberation and action among its members. It's quite an important thing. An idea behind this is the work by Elena Gibaudi and Luigi Cerruti in a past conference like this. What is a chemical substance? Because chemistry is about substance and chemical change of the substances. So the life cycle of the substances might be described as a dynamic pathway that starts in the laboratory and ends up in a waste dump. So we must recognize this trajectory: substance, material, industrial product, good, and waste. In this, about this, the American Chemical Society produces its ethics code, and its ethics code has become international quite recently. The American Chemical Society tried to provide common values across cultures. It's quite a difficult task in a way. In another direction, the European Commission, through his project REACH, aims to improve the protection of human health and environment through the better and early identification of the intrinsic properties of chemical substance. But this is only in Europe. So for me, one of the most important ideas about this is this of Joachim Schumer again, that however science synthesis changed the material world, the gain of knowledge must be compared with the increase of non-knowledge or lack of knowledge, defined by the number of undetermined properties. And this has to be when recent kind of ideas produced by a book like Unknown Science. As much as we know, appears to be that our unknown of the substances increases as well. So, assuming the responsibility manifested by the precautionary principle, the mobilized chemical communities appealing to human beings and all other forms of life, to the present and to the future, will have an outstanding participation in the construction of future. Second scenario. In 1965, the president of the American Chemical Society, Charles Price, wrote, "The setting of the sittings of life as a national goal in the United States." And the Alba rabbit here is an example of that. And this is projected in a way of what's been appeared as the Transhumanistic Manifesto. And likewise, it appeals to the universal engineer, capable of bringing together various things in an acceptable, successful way in order to be able to patent them. This is quite important. This is the case of all those who base it in the way chemicals know, as is the case of Craig Venter, who have been incorporated in the Artificial Life Project. So little by little, with the transhumanist backdrop, we face unexpected situations resulting from the dense interconnectivity present in the chemical practice, resulting from, and this will be quite brief, digitalization. And well, just take a remark from philosophers of science, philosophers. Pierre Laszlo said about this: chemical analysis, taken in a more general way, has replaced matter with a spectrum, with a set of spectra. Bijon Han talked about artificial intelligence, quite related with robotics and combinatorial chemistry. And we see an image produced in a Liverpool lab 1 year ago. Artificial intelligence is apathetic. That is, without pathos, without passion, just calculate. The third one is—
You have 10 more minutes.
Yes, nanotechnology. Nanotechnology, another philosopher, Alfred Norman, said, if an advance in technological control produces a type of technology that eludes sensory perception and human responsibility, this technology turns out to be regressive in that it casts us back to the state of nature. We cannot trust a nominal technology. And the last one is the new chemical companies. And Robert Langer, founder of Moderna, said last year, big pharma abhors risky ideas. So scenario 3, Gustavo, go ahead, please.
Okay, thank you, Jose Antonio.
Yes.
So I have to, oops, can you, oh, well,
yes.
I'll share the screen. Okay. Okay, so the third scenario presented by the Royal Society is that, oops, no, the third, no.
Yes. Oh, yes.
This is the third, sorry. The third scenario presented by the Royal Society is that of a world without chemists. Yeah, they say, well, more people are focusing on subdisciplines and less on the traditionally central areas of chemistry. So there are less people working on pure chemistry, let's say. The first thing that we may wonder about is this not happening also in other disciplines? Is this not happening in biology, in physics, in philosophy? Yeah. Is there really something to worry about? Yeah. Specialization is leading to the disappearance of traditional disciplines. Yeah. And we see that this is going on in biology, for instance. Yeah. More people are focusing on bioinformatics, molecular biology, marine biology, microbiology, biochemistry, and so on and so forth, and less on fundamental biology. Yeah. So what we're witnessing is a different organization of knowledge that is being transformed into different forms of organization. Yeah. And we have to think that disciplinary fields are not monolithic or immutable categories that have to remain the same throughout history. Yeah. So chemistry is today nothing more than the result of the process of shaping a disciplinary field that began in modern times. So the Royal Society is worried about this world without chemists. And we can say, well, don't we live now in a world without natural philosophers? Yeah. We have to recognize that there is a need of specialization. Yeah, specialization in subdisciplines is necessary nowadays. Yeah, first, well, the job market requires specialists. Yeah, Also, the academic world is structured in this in disciplinary fields, yeah, academic departments, specialized journals, all that. Yeah, the development of chemistry, as that of other disciplines, has sorry, I cannot minimize the little windows here, so I don't see the full screen. Well, the development of chemistry, as that of other disciplines, has to do more or towards the creation of subdisciplines such as photochemistry, quantum chemistry, environmental chemistry, etc. Yeah, but there are practical, epistemic, and ethical risks in specialization. Among the practical risks, people are not so easily adaptable to new fields. Yeah, it's hard for people to adapt to new fields. Yeah, there are epistemic risks. Yeah, there's a growing difficulty of communication between specialists from different subdisciplines within the same disciplinary area. Yeah, so people working on biochemistry find it very hard to understand what's going on in other fields like astrochemistry or other subdisciplines of chemistry. Yeah, this fragmentation of knowledge makes collaborative work more and more difficult. Yeah, and more important, this usually entails a one-sided and in a case limited way of seeing the phenomena studied. So if we think that the objective of science is to have the most complete understanding, knowledge of a phenomena, well, probably a specialization is not going to be the way to achieve that, because knowledge is going to be always one-sided. Yeah, and I want to bring here the words of the American sociologist Thorsten Veblen, who talk about, he coined actually the term trained disability. Yeah, and he said, well, certain types of training or specialization can lead someone to be unable to think beyond the set of restrictions and assumption theories with which it has been formed. He said, specialization diverts attention and interest from lines other than those into which a specialization falls, thus widening the field of ignorance of the candidate while intensifying his effectiveness within his specialty. Yeah, so probably we would now talk more about professional deformation. Yeah, but well, I guess you got the idea. And there are also ethical pitfalls. Yeah, because if through a specialization we can reach only a limited or partial knowledge of reality, but an increasingly complex reality is not organized into differentiated disciplines or subdisciplines. Yeah, and so with a partial knowledge of reality, chemistry is not going to be able to achieve many of the world's greatest challenges, the ones Jose Antonio was talking about when he presented the first scenario. Yeah, so we want to argue that there is an ethical obligation of interdiscipline. Yeah, you all know these ideas of Peter Gallison, trading zones, international expertise. Yeah, I'm going to skip this for the sake of time, but we would like to justify this ethical obligation. Yeah, let me remind you also of the words of William Clifford, the philosopher, the 19th century American philosopher, who said, well, it is wrong to believe based on insufficient evidence. So if this is so, then in many cases it seems that an unidisciplinary approach gives insufficient justification. So this is a way of grounding the the idea that there is an ethical obligation of interdiscipline. Yeah, let me go to the fourth scenario, the free market chemistry. Yeah, during the second half of the 20th century, public funding of science, and particular biomedical research, increased steadily in high-income countries to the point that it became the main support of academic research. Yeah, but towards the end of the century, austerity policies and cuts in public spending were established that affected the financing of scientific research in high-income countries. Yeah, so there has been an increase in private funding. Yeah, what you can see here in this graphic is how in the last 40 years or so, there has been an increase in the American funding of science, of private funding, and a decrease of public funding. Yeah. So are we heading towards a free market science? Yeah, there may be positive aspects in the free market model. Yeah, the apologists of free market say, well, you know, there is no more efficient and fair distribution mechanism than the free market. Yeah, it promotes social welfare, economic prosperity, and offering individuals incentives to work hard and produce the goods, the goods and services that others require. They also say the free market is the mechanism that best recognizes the individual freedom and autonomy, yeah, with a certain idea of what freedom means. Yeah, mostly a negative idea of freedom. Yeah, of freedom as no restrictions to individual action. Yeah, so they also say, well, the competition generated by the free market tends to stimulate science in technological research. But we want to call attention to the risk of a free market chemistry. First, it is likely that problems that affect the lowest income countries or the most disadvantaged sectors of society who do not have the means to pay for the goods and services will not be addressed. These needs are not going to be addressed. For instance, well, the needs of the world population do not necessarily coincide with the market. Yeah, let me remind you of this idea of the 10-90 gap. Yeah, 10% of the global health research is devoted to conditions that affect 90% of the global burden of disease. This has actually, the gap has shortened, yeah, in the last few years due to the work that foundations such as the Bill and Melinda Gates Foundation is doing on global health research. Yeah, but anyway, tropical diseases, which are prevalent in many low-income countries, are neglected by big pharmaceutical companies. So the future of chemical research cannot be left completely in the hands of free market, given that this is not even the most efficient mechanism for the distribution of goods and services, nor it is the fairest.
Gustavo, you have like 3 more minutes.
Okay, I'm going to hurry up. Thank you. The second reason is that the free market tends to foster unsustainable forms of development. Yeah, the market usually does not take into account collective goods, those for which no one pays and that are financed with taxes. Yeah, for example, surface water, which is purified and channeled. Well, we pay for that. Yeah, but what about water that comes from underground aquifers, for which there is no payment? Yeah, no, these companies usually don't pay for that water. Yeah, the market usually does not take into account the so-called externalities. That is, the secondary effects that are generated when a company carries out an activity that causes damage to the environment, but does not record or pay, but rather transfer this to the civil society or the state. Yeah. And the third reason of why we're worried about this free market idea of chemistry is that free markets may end up distorting scientific research processes. Yeah. Before the 1980s, a good part of pharmaceutical research was carried out by medical research centers independent of the pharmaceutical industries. And this model changed. Now research depends on contract research organizations, CROs, yeah, in which doctors collect the data from their patients in their offices with instructions from the industry. So they work basically for the industry. Yeah, economic interests have been associated with restrictions on data publication, as well as the promotion of unproven benefits. So we have to be aware of this phenomena, regulatory capture. Yeah, that is something that occurs when a regulatory agency ends up promoting the interests of the industries it claims to be regulating. And we have been witnessing this more and more, yeah, especially in the case of the FDA in the US. Yeah, so we have to be aware of the epistemic risks that this free market model may foster. Yeah, so let me conclude with this idea. Whether the future of chemistry unfolds according to the scenarios presented by the Royal Society or takes other paths, it is imperative that the research or work in this field realize that their work has an I can see that word has an
inescapable.
Thank you, inescapable ethical dimension, that they have a social responsibility, and that the future of chemistry, thank you, is to a great extent the future of
society.
Thank you very much. And that's it. Thank you. Merci. Gracias.
Thank you, Gustavo. Thank you, Jose Antonio. Now it's time for questions. So please, Alfonso, remember, raise your hand in reactions and then raising hand. Thank you.
Okay, congratulations to Jose Antonio and Gustavo Mauricio for your nice talk. I just want to comment to you, maybe you don't know our School of Chemistry, UNAM in Mexico City. We have one subject at the first semester for our chemistry students that deals with these issues of ethical issues, environmental issues. So it's we're trying to develop students, chemistry students that are aware of this kind of problems. And in another aspect, you mentioned the ultra specialization issue, which is very true. We are nowadays, we are doing a lot of research, or we know a lot about a very small part of the world, of the chemistry, but then we lose track of the whole picture. So we need to do a zoom back in order to contemplate, take into account the precautionary principle that you mentioned in your talk. That's all. Thank you very much.
Well, thank you very much for the comment. I didn't know about the work you're doing, so I'm gonna get in touch with you. Now you talk about specialization. Well, there are risks, and we pointed out to some of them. It's inevitable that we head into the direction of specialization. That's a requirement, yeah. But we have to be aware of some of the risks of specialization, yeah, and particularly some of the epistemic risks of this super specialization, and about the fact that these have an ethical implication, yeah, and that's what we want to call attention to. Mm-hmm. Yeah, I don't know if Jose Antonio wants to say something about this.
Yes, well, we agree in the main ideas. Is that the in specialization is one way of training the ignorance. Yes. That's all. Thank you very much, Alfonso.
Thank you, the three of you. So we have a question by Javier, please. Can you unmute yourself?
Yeah, thank you very much for your talk. So I have a I have been thinking about this question. So is in the case with artificial intelligence. As we know, artificial intelligence right now based more on specialization on certain areas. For example, a neural network or any system is trained in a specific system, right? So I am kind of worried that artificial intelligence takes human activity in developing scientific theories. Actually, science can get very worse because sometimes it requires the mixing of several groups, like for example, physicists, chemists, and also perhaps, I don't know, economists in some cases. So if we let artificial intelligence as the way it is developed right now, I fear that the sciences cannot progress. Thanks.
Oh. We are not saying that with artificial intelligence, science will not progress. We are now using artificial intelligence. The point is that we must keep an eye constantly in how artificial intelligence is used and is produced for what purposes. That's the point.
But I mean, for example, if you see how some areas of science came into existence,
Yes.
it required mixing much more than one field. For
Yes.
example, cybernetics. Cybernetics is part neurophysiology, part mathematics. So if you don't have humans that talk together, that are from different areas, you can create some new areas for understanding something new. And that's quite of why I'm a little bit worried. Maybe in one discipline, it can be useful, for example, to find patterns that are hidden to ourselves. But there are some times that you need an opening to another scientific world to make a better understanding of a phenomenon. So that's kind of my concern.
Yes. Yes, this transhuman approach of an cyborg creature in the future, which is now not a future, it's now around us in a way, is quite a difficult task to understand clearly. Yes, that's one of the risks of the future. Thank you.
Thank you all. Now let's move to Farsad.
I'll just be very quick. I really appreciated the talk. So important. I have a colleague who talks about the pharmaceutical industrial complex, and then I discovered Sergio Sismondo, who has written a lot about science technology studies, has an entire book just on that called Ghost Managed Medicine, Big Pharma's Invisible Hands. I put it into chat.
Thank you.
But it's a growing concern, and it's so huge. I really appreciated how much you brought all that to light. That's all I just wanted to add. Thank you.
Thank you.
Thank you for that comment. Yeah.
Thank you. Michelle, please.
Yes, I really appreciated the talk, and thanks for explaining what the Royal Society is up to more recently, and they're right to be concerned about these things. Just one thing about the collaboration between industry and academics on developing chemical processes. It's a complex relationship because also the cultures are very different. The industry people want to keep everything secret. The academics want to share everything that they've discovered. And then there's negotiations and the negotiations are not always very clean, and the academics are sometimes a bit naive. And so this adds another layer of complexity to the whole idea of the science. So just to dampen things even worse. And also, and I'm going to say things that sound a bit contradictory about economics. One is that it's not clear that there's any such thing as really a free market, right? The markets are actually very controlled in many ways. On the other hand, but regardless of that, you're right to, I mean, the Royal Society and you are right to be concerned about the free market because distribution is that's not part of the economic calculations. And in fact, they're much worse than a lot of people think, because a lot of people think it's more or less linear, but it's actually a curve, right? So if you leave a kind of free market system, they've done simulations of this, then you end up with a very small number of people that are very, very wealthy and a huge number of people who are very poor. So the middle class gets pushed away, in other words, and they all, 90% of them move towards the bottom. So it's not even as though it's a sort of, random distribution or something. So just to, and that's why we don't have a real free market, is because then you lose the middle class. So
Okay. Thank you.
Yeah, well, let me say something about this. You're right in that industry tends to be very, very secretive. I'm not so sure that scientists want a more open model of science. Yeah, there are some pros and some cons in an open science model. Yeah, and many of the part of the system on which we rely is based on a very close and very limited way of spreading knowledge. Yeah, think for instance about publishing houses and journals and how they're part of that system that is opposed to an open science model. Yeah, so it is not only the industry on the one hand and science on the other. Yeah, and we should devote more time to think about the advantages and disadvantages of an open science model. Yeah, and probably we don't have time to do that now. But let me say something about what you mentioned about the free market. There is no such thing as about the free market. You're right. Yeah, the neoliberal model of the free market requires that there is a strong state regulating the freedom of the market in a way. Yeah, there have to be regulatory agencies trying to protect the interests of the industry, but at the same time the interests of consumers, etc. Yeah, so it is not a completely unregulated market. Yeah, the market has to be regulated, and a free market requires the strong presence of the state and regulatory agencies. And what they're opposed to is to a strong regulation by the state. Yeah, but yeah, I agree. There is no such thing as the completely unrestricted market.
Thank you very much, Gustavo. We have a question by Jeffrey, please.
Yes, thank you very much for the excellent presentation. I would say, as a way of background, that my initial interest in the philosophy of chemistry and of science in general began more than 50 years ago with the notion of risk assessment and how risky is exposure to a chemical. And so I have followed your arguments very carefully, and I find them to be full of wisdom. And I will only focus on one particular aspect here, and that would be the conundrums involved with the use of logic and its relationship to your statement of specialization breeds ignorance. And this is a profound statement. This is a very profound statement in my system of ethics, because one sees this so often, not just in the science. Well, it's particularly common in the sciences, I guess is the way to put it, and in communications among the sciences. And efforts to paper this over with different symbolic logics, and the different symbolic logics that have been developed for the sole purpose of economics, basically, and communications technologies, is just a severe constraint on how society looks at the sciences, how society looks at truth, how artificial intelligence is to be applied to objectives, etc. It's a very deep conundrum that you're bringing to light of specialization breeds ignorance. Thank you.
Well, thank you for that comment.
Yes.
We completely agree. Yeah, specialization breeds ignorance. Yeah, so that's why we need a much more collaborative way of working.
That's the point.
Well, thank you very much, everybody. If nobody has any more questions, I'm going to check people who are up in their cameras. If any, no. Seems that we are done for the day. Thank you very much.